donating my truck for this project, and what's inside here is a instrument that measures methane concentration instantaneously, precisely, and accurately as you drive, and plots to an iPad or a tablet in the passenger seat, and you can watch the color-coded concentration of methane change as you drive, and it plots it on Google Earth, actually Google Maps. And so what we're doing is we're using this vehicle to characterize what the methane emissions are in any basin of choice. So lately we've been working in the Denver-Julesburg Basin, and so my mission is to try to use not only methane concentration but methane isotopes. So C13 of methane is a great tracer for what kind of methane we're seeing. And this instrument inside the truck will do that by sniffing the air that we're driving through off the top of this mast, or if I'm looking for urban leaks, I can pull in air off the front bumper. I can switch all that from the interface inside the vehicle. On the top, you'll see a funny looking thing that people think I'm a Ghostbusters or Google Earth something. It's a sonic anemometer, and so it measures the wind speed and direction, and the precision GPS both feed into the computer, and it subtracts the vector of the vehicle, and the wind gives me the true wind. So it's important to know where the air mass is coming from that you're measuring. If I have an oil and gas well on the right hand side of the road and a big feed lot on the left hand side, well, who's giving me the methane? That will tell me. And what this is way more here than you can want to digest right now, but basically the short story is that we have a different isotopic signature coming from cows than we do from landfills or from oil and gas. And so we can use that as sort of a mixing model to look at what the sources are. This sort of explains what's in the back of the truck. This explains the interface and what it looks like, and I can show you on here or on the pad inside the truck. And these are plots of plumes that we've discovered in the Weld County area, and here I've characterized them by color. So the red ones are ones that, based on metadata from the field and the isotopic data, I have determined are from oil and gas. The green ones are from controlled animal feed operations, dairies, feedlots, that sort of thing. The light green is sheep. They're not very productive. And then the yellow ones are from landfills, and some of these can be quite productive. And also some of these are seasonally variable. So you can imagine manure and decomposition in a landfill are not so active in the winter, but oil and gas is pretty much year round. We can use other gases as tracers for oil and gas emissions. Ethane is one of them. This instrument measures it, but it's not really calibrated or designed to do that. It also measures CO2, water vapor, a whole host of other things. What's amazing to me is this is all inside a box the size of maybe a very old-fashioned stereo. And that takes a place in the rest of my work life is I run a laboratory that measures these things with mass spectrometers that cost $250,000 and are the size of a large desk and take a trained technician to run. And this is a box in the back, and it has one button. I love it. So you're welcome to take a look at the back. What I can show you here is that we sort of characterize the plumes and where they're located and what we think are their sources. I've verified that by using what's called a FLIR camera. Is anyone who knows what a FLIR camera is? Anybody? It stands for forward-looking infrared. It's basically like a thermal imaging camera, very similar to what someone would look at your home and tell you where you need insulation. But it's got a bandpass filter on the lens at 3.6 micrometers that filters out all but that which is coming in that wavelength where methane or VOCs are absorbed. So you can see a methane leak as if it were campfire smoke, and what you can't see with the naked eye. And it's about a $100,000 camera. I don't own it. I borrow it from the Regional Air Quality Council. It's about the cost of the instrument. And here I've got some still images from what it looks like. And so I've been wanting to demonstrate what is it from oil and gas that's leaking. What are the real sources? Is it the wellheads? Is it the combustion? Is it the separators? Is it the condensate tanks? Is it the produced water tanks? What is it? Pipelines? And so this allows us, when we see a plume and we're on public roads, we can get close enough, we can actually image what it is. So here's a picture of a condensate tank that's leaking out of the thief hatch on the top. This is a produced water tank. It looks like a smokestack, but I guarantee you would see nothing with your naked eye if you saw this. So that allows us to verify the sources, and there's another part of this that's a little more complex, but because I can measure isotopes, I need time in the cavity of the instrument. You don't get them quite as well instantaneously. So the workaround for that is to collect a buffer volume of air while you're driving and then analyze it later more slowly, and then you can get the numbers. And this is done actually automatically by the interface. If I go through a plume and I want to say, oh, that was a very interesting plume, let's analyze it isotopically. I push a button and it reanalyzes a volume of air it's been storing in a 50-meter tube, and it's like kind of like a tree core or something. So you can switch valves and analyze the air in that tube, last in, first out, and you get like a time series history of what you drove through in the plume, and it spreads it out. And then I can do some plots, and it'll give me sort of the source signature of what that plume is if it was pure methane from that source, if that makes sense. So we take that concept and we take it one further, and I have a 1,500 foot coil of tubing in the car with a quarter ID with pumps and mass flow controllers on either end. And I can drive around and get a sample that I can later analyze more slowly to get an aggregate isotopic signature. So not only do I have signatures of what the plumes are for these individual places, but I can see what's on average, what am I seeing? And I call this the megacore that I've developed with some collaborators in the company. And the time I do this is about 3 in the morning. Not very popular with my wife in those days. But I go out there to measure that time because the atmospheric boundary layer is down very low. The air is calm and still. And so emissions from any source, feedlots, landfills, oil and gas, have had a chance to accumulate from likely sundown. And I'm interested in that because when the wind blows things away, you can have a very powerful source from far away that looks the same as a small source close up. So it's very easy to get confused. So this is a way to sample an aggregate of the area. And I can tell you that as you go down these slight topographic lows, I'm not seeing plumes, it's just an aggregate elevation in methane of several ppm. So background for the record is about 1.9 parts per million of methane globally. We measure it on my lab, so I know this very precisely. When we drive out into the Weld County and go down in these low-flying areas, we're seeing 2, 3, 4, 5, 6 ppm methane. And the methane, by the way, I want to point out, it's not going to kill you. Methane's just fine. I could probably take a mouthful, it's great. But if it's in the oil and gas upstream, what we call from the production pad, it oftentimes is accompanied with other volatile organic compounds: ethane, propane, butane, benzene, toluene, xylene, all these other things you may not want a lot of. So I'm hoping to be able to leverage this technology to work with other people who can make those measurements, which I don't, and maybe we can get an idea about what concentrations are out there in what I would call the soup. But we live in Colorado where it's windy, and by sunrise the wind comes up and it's all gone. So dilution is not the solution, but we're out there trying to measure it. And if you want to see the interface, you're welcome to have a look or just poke around in the back. Be my guest. I'm happy to answer any questions.
Are any of the Google Map type data points that you have there, are they readily available, or is that not something?
No, and I do that with purpose, and I'll tell you why. Because part of the reason is that this is preliminary data, and when I first started taking this, I sort of thought I had things characterized isotopically. Turned out that upon further QA/QC, I had an ethane correction in the spectroscopy to do, and so it kind of shifted the whole isotopic thing. Had I released that, and people would have been going, "Hey, wait a minute," I was like, "Well, I'd say, well, you know what? That's not quite exactly right." So the scientists were kind of conservative, and we like to sort of make sure all our ducks in a row before we actually release it. And we will be, you will see it in published papers. So, and that's the irony and the difficulty of this is our need for information in the public sector for decision makers and policymakers is far more urgent than the normal track for the scientific measurement, that, calculation, post-processing, publishing. That is a longer timescale, and that's frustrating to all of us.